This is SpaceTime, Series 28, Episode 31, for broadcast on the 12th of March 2025. Coming up on SpaceTime, confirmation of beaches on the red planet Mars. A new study shows that water, essential for life as we know it, appeared much earlier in the history of the universe than previously thought. And NASA's been forced to turn off instruments aboard the Voyager spacecraft in order to keep the mission alive. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
China's Zhurong Mars rover has now confirmed that ocean beaches once covered the red planet's northern hemisphere. Orbital images have long suggested that the Martian northern hemisphere lowlands are the seabed of a long-gone ancient ocean and that this ocean was surrounded by beaches and shorelines. Now a report in the Journal of Proceedings of the National Academy of Sciences claims a ground-penetrating radar instrument aboard Beijing's Zhurong Mars rover has identified hidden layers of rock under the planet's surface that strongly suggest the presence of an ancient beach. It means the red planet may once have been home to sun-soaked sandy beaches with gently lapping waves. The new research offers the clearest evidence yet that the red planet once contained a significant body of water and consequently a more habitable environment for life. Zhurong landed on Mars in 2021 in an area known as the Utopia Planitia and sent back data on the geology of its surroundings in search of signs of ancient water or ice. Importantly, unlike other rovers, Zhurong came equipped with the ground-penetrating radar. That allowed it to explore the planet's subsurface, using both low and high-frequency radars to penetrate the Martian soil and identify buried rock formations. By studying the underground sedimentary deposits, scientists are able to piece together a more complete picture of the red planet's history. And the radar data has revealed a similar layered structure to what we find at beaches on Earth. These are formations known as foreshore deposits. They slope downwards towards the ocean and form when sediments are carried by tides and waves into a large body of water. It all suggests there were waves. That means there was a dynamic interface of air and water. Now, all this is important because when scientists look back at where the earliest life on Earth developed, it's thought to have been in the interaction between oceans and land. So this paints a picture of ancient habitable environments capable of harbouring the sorts of conditions which would be friendly towards the establishment and continued survival of microbial life. After all, that's what we find here on Earth. When the authors compared the Mars data with radar images of coastal deposits on Earth, they found striking similarities. The dip angles found on Mars fell right within the same range as those seen in coastal sedimentary deposits here on Earth. The researchers also ruled out other possible origins for the dipping reflectors, such as ancient river flows, winds, or ancient volcanic activity. They suggested the consistent dipping shape of the formations, as well as the thickness of the sediments, all points to a coastal origin. They were seeing what were definitely shorelines in this body of water which had evolved over long periods of time. The discovery is further evidence that Mars was once a much warmer and wetter place than the freeze-dried desert it's become today. Aaron Cavosi from Curtin University says the study provides new information on the evolution of the Martian environment, suggesting that a life-friendly warm and wet period must have spanned potentially tens of millions of years on the surface of the red planet.
Well, this is really the first time that someone has put boots on the ground, so to speak, and been able to do some in situ observations to test the Northern Hemisphere ocean model that has been proposed for a couple of decades now. And so it really is a game changer to be able to make measurements on the ground, and the radar that they used really was unprecedented in terms of what it showed. It was able to go relatively close to one of the shorelines, and there's been this proposal that there's from space imagery, satellite imagery, there's almost a girdle around about the northern third of the northern hemisphere. And this has been interpreted to be a shoreline where the ocean would have been to the north in the northern lowlands, as they're called. And the rover was able to actually go along a transect, meaning a perpendicular line away from this shoreline, and imaged the rocks underground along this transect to see if they met the right kind of characteristics in a couple of different aspects that they looked at that one would predict for rocks deposited in an ocean basin. So that was what they set out to do, and it was a quite fascinating result.
Do we know how deep this ocean could have reached?
It's interesting. There have been some studies that have looked at that, and I'm going to be careful with any numbers I cite because I haven't consulted that recently. But my sense was these were on the order of a few hundred meters rather than many kilometers. Then there's over the life of the ocean, how that depth may change. I kind of like that you're asking that question because that sort of presupposes that an ocean did indeed exist. If we're talking about what the depth of it might have been, it kind of means that we're at a state where the data for the existence of an ocean are pretty good, and I agree with that. I think we're approaching a point where questions about the ocean depth and its longevity are important to address. Certainly, there had to be a fair depth of standing water over time to develop the types of deposits that were imaged by the rover. And that's about as far as I want to go on the depth of water because pretty much any number you put out there, I think someone's going to find some issues with until we have better constraints on that value.
I guess the other big question has to be what took place at the rock-ocean interface. Here on Earth, this is where a lot of biologists believe life began.
Well, that's the question that is now rising to the top of the list, I think. If the suggestion or the proposal or the model for standing water through this time period of Mars that is called the Hesperian. The Hesperian period goes from about 3.7 down to about 3 billion years ago. And again, the kind of canonical wisdom on this time period when we're not talking about the notion of an ocean is that this is a time period where there's not a lot of other types of evidence for standing water. And so it's thought to be the kind of a transitionary period where Mars got cold and dried up and surface water was no longer stable. There are spectacular images starting from Mariner 9 in the 70s and much more recent data that show spectacular channels, large canyons cut across Mars during this time period, but they're all thought to be reflective of catastrophic releases of groundwater rather than standing water. And all of a sudden, we're talking about an ocean at this time period. So that's a really different concept or interpretation for water on Mars during the Hesperian. The question, back to your question, which is spot on, anywhere you see water and kind of at the rock interface, the shoreline interface, if you will, let's even call it a beach because these are coastal deposits and hence beach deposits. Those are environments that are absolutely ripe for exploration for anything that might have found habitability within that environment. If there were things living on Mars, the shallow waters along a coast would be a spectacular place to look for evidence of what that environment may have contained. And so I think it's breathtaking, really, if you think about this global ocean on the northern third of Mars in the lowlands. If indeed that was a pool, planet-sized pool for harboring life, potentially there would be many, many locations along that shoreline that could be examined to see if there's any evidence of organisms that might be entrained in the rocks that are unique to that environment. That's pretty bloody exciting, if you ask me.
Mars and Earth have been swapping rocks for billions of years, so who knows? The famous Allen Hills meteorite from Antarctica, the Martian meteorite, the one that has unusual crystals inside it, microscopic-sized crystals inside it. If you didn't know it came from Mars and instead thought it came from Earth, what would you say those crystals were? ALH84001 is definitively one of the most famous Martian rocks that's sitting in collections on Earth for all of the reasons you just mentioned. It galvanized thinking and science. It really, perhaps in one sense, almost created the field of astrobiology on Earth because it brought up a simple question that was a giant, important question. How do we know how to recognize life in rocks?
particularly at this scale. What tools are effective? What's the efficacy of the methods? What's the veracity of this approach? How is it that we can come up with a compelling, scientifically rigorous conclusion?
That was the problem with the first Mars landers, wasn't it?
Well, indeed. I would say, let's change it from problem to a challenge. And how do you make detections that are definitive, whether it's measuring gas from biking or whether it's a photo observation or a chemical measurement of an isotope? How do you make definitive measurements? I'll try to be honest. I think if that rock, the Allen Hills rock, were put in front of me today and no one told me it was from Mars, and I first looked at it and I saw the carbonates and the magnetite grains that were a lot of people were excited about and spent quite a long time discussing, my first gut reaction probably would have been to interpret them as some type of biological form.
Everyone I've spoken to has given exactly the same answer, by the way.
So this isn't a litigation of the initial study authors. This was McKay and colleagues at NASA. This is just a response as a microscopist and a geologist that looks at rock for a living. And what's in those images is unusual. It doesn't look like an inorganic object. So the conclusions of that initial study, or the proposal rather, that this is evidence of life in a Martian rock, it got everyone's attention, I'll tell you that. And I would say ensuing decade, or probably two or more, because that was, 1996 that proposal was put forth. I remember the press conference. That really galvanized the community to say, okay, buckle up, get your seatbelt on. Let's figure out ways to actually test this idea with this rock, and going forward, what new methodologies do we need? My sense, and I'll try to, again, say this with a transparency and some honesty, but my sense is that there may be some people that still adhere to the original interpretation that the initial evidence represents some type of biological activity. But I would say that the majority of people I interact with or encounter look at that and say it's a series of non-diagnostic types of evidence that are circumstantial. They all are consistent with, but there wasn't a single one that was a diagnostic gold standard signature of life. So it was a bunch of different types of information, from morphologic to organic chemistry, that were put all together and really are very strongly suggestive, I would say. But the emphasis here is on identification of that gold standard evidence. What is that one bit of evidence that does not have another explanation and therefore is sort of in a category of its own? It does not need a bunch of other lines of evidence, because that observation or that measurement or whatever the data are sufficiently unique and diagnostic of the process of life. I think it's fascinating. That's one of the most studied meteorites ever. And it has really, I would say, changed the community and changed the perspective of science to really address this issue of how do we look for life elsewhere, and what do we need to find to be confident that we found it, when indeed we do, or when we think we do at any rate. So it's a fascinating adventure and a fascinating journey that started with this lonely rock collected in Antarctica.
Carl Sagan, I think it was, who said extraordinary claims require extraordinary proof. But Mr. Spock from Star Trek probably said it best when he said fascinating. Thank
Indeed.
you.
Stuart, live long and prosper.
That's Aaron Cavosi from Curtin University. And this is SpaceTime. Still to come, a new study shows water appeared earlier in the history of the universe than previously thought, and NASA's been forced to turn off several instruments aboard its Voyager spacecraft in order to keep the mission going. All that and more still to come on SpaceTime. A new study shows that water, essential for life as we know it, could have emerged far earlier in the history of the universe than previously thought. The new findings, reported in the journal Nature Astronomy, show that water was already present in the universe just 100 to 200 million years after the Big Bang, 13.8 billion years ago. The discovery means habitable planets could well have started forming much earlier, in fact before the first galaxies formed, and billions of years earlier than what was previously thought. The study's lead author, Daniel Whalen from the University of Portsmouth, says it's the first time that water's been modelled in the primordial universe. Now, according to the new simulations, water molecules began forming shortly after the first supernova explosions. These are known as population 3 supernovae. These cosmic events only occurred during the first generation of stars, and they were essential for creating all the heavy elements of the universe, including oxygen, which is required for water to exist. See, when the universe formed and things cooled enough for the first atoms to come together, there was only hydrogen and helium, with only tiny trace amounts of lithium and beryllium. And so hydrogen and helium became the ingredients for the first stars, weird monsters known as population 3 stars. These were massive, superluminous blue giants, tens to hundreds of times larger than our Sun. But being so big means they burnt through their nuclear fuel supplies really quickly, consequently only had very short lifespans, exploding as supernovae. During their lives, and when they exploded, they produced all the other elements on the periodic table, including oxygen, which is required for water to exist. The key finding of this new study is that primordial supernovae from these population 3 stars formed water in a universe that predated the first galaxies. Whalen points out that before the first stars exploded, there couldn't have been any water in the universe because there was no oxygen. Oxygen forged in the hearts of these supernovae combined with hydrogen to form water, paving the way for the creation of the essential elements needed for life as we know it. The researchers examined 2 types of supernovae: core-collapse supernovae, which produce a modest amount of heavy elements, and the much more energetic population 3 supernovae, which eject tens of solar masses of metals into space. For astronomers, all elements other than hydrogen and helium, the elements created at the Big Bang, are considered metals. Their models show that both types of supernovae form dense clumps of gas enriched with water. Although the total water masses were modest, they were highly concentrated in the only structures capable of forming stars and planets. And that suggests that planetary disks rich in water could well have formed during the cosmic dawn. This is SpaceTime. Still to come, NASA forced to turn off instruments aboard its Voyager spacecraft in order to keep the mission going. And later in the science report, a new study destroys the common stereotype that women are more romantic than men. All that and more still to come on SpaceTime. NASA's been forced to turn off 2 science instruments aboard the Voyager spacecraft. The decision allows the probes to conserve energy and consequently extend their missions. Launched back in 1977, the twin Voyager spacecraft are the most distant man-made objects in existence. Both are flying through interstellar space well beyond our solar system, with Voyager 1 now more than 23 light-hours away from Earth and Voyager 2 some 19.5 light-hours away. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, turned off the cosmic ray subsystem experiment on Voyager 1 on February the 25th, and is shutting down Voyager 2's low-energy charged particle experiment next week. That means just 3 science instruments will continue to operate on each spacecraft. The move's all part of ongoing efforts to manage the gradually diminishing power supplies aboard the probes. See, Voyagers 1 and 2 each rely on radioisotope power systems. They generate electricity from the heat of decaying plutonium, and each of these systems loses about 4 watts of power a year. JPL Voyager project manager Suzanne Dodd says the electrical power systems are now running low. If an instrument isn't turned off on each Voyager now, they'd probably only have a few more months of power before NASA would be forced to declare end of mission. The 2 spacecraft carry identical sets of 10 scientific instruments. Some of the instruments, geared towards collecting data during planetary flybys, were turned off after the 2 spacecraft completed their grand tours of the outer solar system and its gas giants. The instruments that remain powered on well beyond the last planetary flybys are those the science team considered important for studying the solar system's heliosphere, the protective bubble of the solar wind and magnetic fields created by the Sun, separating it from interstellar space, the region outside the heliosphere. Voyager 1 reached the edge of the heliosphere and the beginning of interstellar space back in 2012, and Voyager 2 reached the same boundary in 2018. So far, no other spacecraft has reached interstellar space. Last October, mission managers turned off Voyager 2's plasma science experiment. It measures the amount of plasma, that's electrically charged particles, and the direction they're flowing. That instrument had collected only limited data in recent years due to its orientation relative to the direction the plasma was flowing in interstellar space. Voyager 1's plasma science instrument was turned off years ago, but that was because of degraded performance. The cosmic ray subsystem that was shut down last week aboard Voyager 1 is a suite of 3 telescopes designed to study cosmic rays, including protons both from the galaxy and the Sun, by measuring their energy and flux. Data from these telescopes helped the Voyager science team determine exactly where and when Voyager 1 exited the heliosphere. Voyager 2's low-energy charged particle instrument measures various ions, electrons and cosmic rays originating from our solar system and from the galaxy beyond. It consists of 2 subsystems, the low-energy particle telescope for broader energy measurements and a low-energy magnetospheric particle analyzer for more focused magnetospheric studies. Both these systems use a rotating platform providing a 360-degree field of view. The platform is powered by a stepper motor providing a 15.7-watt pulse every 192 seconds. That motor was tested to 500,000 steps, enough to guarantee continuous operation through the mission's encounters with Saturn, which occurred in August 1984 Voyager 2. By the time it's deactivated on Voyager 2, that motor will have completed more than 8.5 million steps. Mission engineers have gone to great efforts to avoid turning off science instruments as long as possible because the science data being collected by the twin probes is so unique. After all, they're the only machines operating in interstellar space. But with these 2 instruments turned off, the Voyager should have enough power to operate for roughly another year before the team needs to shut off another instrument on each spacecraft. Meanwhile, Voyager 1 will continue to operate its magnetometer and plasma wave subsystem. The spacecraft's low-energy charged particle instrument will operate through the remainder of 2025, but it too will be shut down next year. Voyager 2, meanwhile, will continue to operate its magnetic field and plasma wave instruments for the foreseeable future. But its cosmic ray subsystem is scheduled to be shut off in 2026. With the implementation of this latest power conservation plan, engineers believe the probes have enough electricity to continue operating with at least one science instrument well into the 2030s. But they're also mindful that the Voyagers have been weathering deep space for 47 years now, and that unforeseen challenges could shorten that lifespan. Voyagers 1 and 2 remain the most distant man-made objects ever built. Right now, Voyager 1 is more than 25 billion kilometres away, and Voyager 2 is over 21 billion kilometres from Earth. This is SpaceTime. And time now for another brief look at some of the other stories making news in science this week with a science report. A new study has destroyed the common stereotype that women are more romantic than men. Research by the Humboldt University of Berlin has shown that it's actually men who tend to be more focused on entering into a romantic relationship than the female of the species. The findings show that relative to women, men expect and receive greater lifestyle benefits from entering into a romantic relationship, and they're also more likely to take breakups worse. The authors say the data clearly shows that steady relationships are psychologically more important to men than women, and this demonstrates differences in how men and women navigate social networks and their emotional needs. The research is based on more than 50 scientific studies on gender differences in heterosexual relationships. Future studies in homosexual ones are yet to be undertaken. The work also found that not only are men more focused on entering into steady relationships, their well-being and health benefit more from such relationships than women. Even the life expectancy of men is more strongly associated with being in a steady relationship than that of women. Researchers also found that men are less likely to initiate a breakup, and they're more likely to experience loneliness following a breakup. Well, we thought it had disappeared in the middle of the last century, but doctors have undertaken electroshock therapy focusing on kids with ADHD. But the research, reported in the Journal of the American Medical Association, has returned mixed results. Technically known as transcranial direct current stimulation therapy, the work on 69 children involved shocking an area of the brain called the left dorsolateral prefrontal cortex. But they found it lowered the accuracy of children's working memory, the part of the short-term memory that processes perceptions and language in the moment. However, shocking another area, the right inferior frontal gyrus, improved children's interference control, which is the ability to resist distractions and ignore irrelevant information. The authors say the results suggest targeted electroshock therapy can affect brain regions relative to ADHD in kids, and future work should explore it as a treatment option or carefully controlling for any adverse effects. A new study claims eating walnuts for breakfast could improve brain function throughout the day. A report in the journal Food and Function found eating just 50 grams, that's a generous handful of walnuts mixed into muesli and yogurt, led to faster reaction times throughout the day and better memory performance later in the day when compared to eating an equivalent calorie-matched breakfast but without the walnuts. The study involved 32 healthy adults aged 18 to 30 who consumed both a walnut-rich breakfast and a matched non-walnut breakfast on separate occasions. Participants then completed several cognitive tests while their brain activity was monitored in the 6 hours after eating each breakfast. The findings build on previous research showing the cognitive impacts of regular nut consumption, including walnuts. Brain activity recordings revealed changes in neural activity that suggest walnuts may help the brain work more efficiently during challenging mental tasks, while blood samples revealed positive changes in glucose and fatty acid levels, both factors that could influence brain function. The researchers suggest that walnuts' mix of nutrients, including omega-3 alpha-linolenic fatty acids, proteins, and plant compounds called polyphenols, may enhance cognitive performance. Now, it's important to note that the research carried out by the University of Reading was funded by the California Walnut Commission. However, the funders had no role in conducting the study or interpreting the results. Apple has just launched their latest iPad. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The 11th generation base level iPad has now been launched. The 10th generation, actually, from a couple of years ago, was the one that took the base level iPad and made it have the swipe interface, not the home button. But the newest one that was launched this year continues in that vein. But instead of being $449 US, it's back to $349, which is only $20 more than the $329 that the iPad launched at all those years ago. In fact, I can't even remember. It might have been cheaper, but it certainly fell to $329, and it was a bit of a shock when it rose in price. Now, a lot of people thought that this
have one of those original iPads.
Yeah, no, I've got one too, and look, I haven't turned it on in many years, but they certainly were. Yeah, but they were incredible at the time. A giant iPhone, as people call them at the time. Now, this particular iPad, unlike every other iPad, doesn't have Apple Intelligence. It's got the A16 processor, which I think is about 30% faster than the previous processor, but no Apple Intelligence. Even the iPad mini, which came out late last year, has Apple Intelligence. So Apple has chosen not to put that in, but that's because they'll sell gazillions of these, and a lot of people are not going to use those AI features. They'll use this as an entertainment device. You can still run Pages and Word and Google Docs and all the different apps and games that are available, but they did not put in Apple Intelligence. So it clearly doesn't have 8 gig of RAM, but what they have done is they've doubled the storage to 128 gig minimum, and they've lowered the price from the $449 from a couple of years ago. So clearly Apple has decided that it's just not worth putting Apple Intelligence in at this price point. And if you do want that, and other features like a laminated screen, which makes the screen look closer and sharper and nicer and better, that will come in next year's iPad or the one in a couple of years' time. Now, Apple also launched the iPad Air with the M3 chip. They launched it with the M2 chip last year, and this is clearly a more powerful device. But moving on to the MacBook Air, they launched the M4 version of the MacBook Air, and it's got 12 megapixel camera with center stage, and it can do the desk view where it looks as though it's looking at your desk. They also launched the new Mac Studio one that can take up to 8 monitors at the same time. So look, we've had the new 16E a couple of weeks ago, new iPads, new Macs. Now we have to wait till April to get iOS 18.4, where we will get hopefully some more Siri improvements.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.